Hello everyone, and welcome to the Mat 211 review of sets and cardinality. My name is Julia, and I work for the tutoring centers at ASU. So, given that n of A, or the number of elements in A, is equal to 100, n of A union B is equal to 200, and n of A intersect B is equal to 35, find n of B, or the number of elements in B. That's what this little function here is trying to say. So this sort of problem is best done by drawing pictures. Specifically, Venn diagrams are very useful in this case. And as it happens, someone very nicely started drawing a Venn diagram for us. So let's use this. So the first thing we want to do is we want to label each of these circles either A or B to represent our two different sets. And we know they intersect because this A intersect B here is a positive number. So we know that there's got to be at least something in this space here where they overlap each other. So let's go ahead and make this one A and this one B. Now, let's think about what our different numbers mean here. So first, we have the number of elements in A is 100. So that means that this whole circle here, which I'm going to try to loosely shade with lines as best I can here with the tablet. There we go, that's good enough. So that whole circle there is going to have 100 in it, 100 of whatever is in our sets in it. Now we have A of the union of A and B is 200. Let's leave that for a second. Let's actually do, clear here. Oh shoot, let me do that again. Press the wrong button. Gotta love Zoom. There we go. So there's our A, and there's our B, and there's 100 in there. Okay. So now, let's look at the intersection between A and B. So that is this region here. This little sliver here, because that's where the intersection is where A and B overlap. So we know that in there, there's 35. Make that nice and bold. There we go. Now lastly, let's look at this, make this red. Let's look at this guy here. So n of A union B is 200. And that refers to everything that is in either A or B. So that is the entire space covered by the two circles. There we go. There we go. Something like that. All right. And that entire space has 200 elements in it. So now we are looking for all of the elements in B. So everything, let me make my pen a little bolder here. Everything in this circle here. But we're not given that. We're given these other values, but we can work backwards to get to that circle. So let's first think of what we have. We know that we have A and B, and there's 100 or 200 elements total between A and B. And if we kind of look at this, well, the whole space, the whole like figure 8 shape here is our A and A union B, right? And if we just subtract it off, the part of A that doesn't include this little center area here, so it doesn't include this space, then we would get our B as a remainder. So first, let's figure out what this little like crescent moon part of A is. So if we say A, n of A minus our little sliver in the center here, this part, I'm just going to keep scribbling all over this. So if we minus this little sliver in the center from the whole of A, so that's going to be n of A intersect B, remember, then that'll give us our value. So that equals 100 minus 35, which equals 65. So switch to a color here. This area just in this little like crescent moon here, that kind of shape, that's going to be 65. So now, since we know the value of everything in both A and B, we can just simply subtract off this little crescent moon shape, which has 65 in it, to get the number of elements in just B. So let's do that. So that would be n of A union B minus this whole thing here. So minus n of A minus n of A intersect B, which we could also write as n of A union B minus n of A plus n of A intersect, whoop, not A, not two A's, intersect B. There we go. So, and that's true, that becomes a plus because we have a minus here and we're minusing this whole quantity. So when that minus distributes over to this minus, the two minuses cancel out. So we get a plus again. So, but we already figured this out. So this is going to be n of A union B, which is 200, minus this whole quantity here, which is 35. And that equals, oh no, it's 65. There we go. Because that's that whole thing there. And that works out to be 135. So n of B has 135 elements. And that's our answer. There we go. So before I go, I just want to remind everyone that if you are looking for any additional tutoring or academic support services at ASU, please visit the Tutoring Center's website, tutoring.asu.edu. And there you'll be able to find all of our resources. Now, if you're looking for tutoring services for your specific course, you can use our Tutor search tool, which you can find at our main webpage here, or by going to this full link. And that will allow you to search for all of our tutoring services for your specific course. So thanks so much and have a great rest of your day.